The Unwritten History, How the Universe, Earth, and Moon Were Born. Hook and intro. What if I told you that everything you see, everything you feel, everyone you know, all sprung from an event so cataclysmic, so mind-bendingly powerful that it defies our very imagination? What if the ground beneath your feet, the very air you breathe, and the moon that lights our night sky are all relics of a violence on an unimaginable scale, a cosmic dance of creation and destruction that played out billions of years ago? We live on a planet born from fire, shaped by impact, and stabilized by a celestial companion that literally saved us from chaos. We are the improbable children of a grand cosmic narrative, a story written in starlight, sculpted in rock, and whispered by the very fabric of space and time. This isn't just a tale of ancient history, it's the genesis of everything. It's the story of how the universe itself came into being, how our solar system found its place in the vast cosmic ocean, and how our home, Earth, was forged in a crucible of heat and collision. Crucially, we will uncover the dramatic tale of the moon's violent birth, an event that didn't just give us a beautiful nightlight, but was absolutely critical for our very existence. Without that colossal impact, without that cosmic accident, life as we know it might never have had a chance to bloom. Imagine, if you can, a time, before space, before matter, before anything. Then, an instant of unimaginable density and heat, a singularity bursting forth, creating the very stage upon which this epic drama would unfold. This isn't a theory from ancient texts. It's the scientific consensus, painstakingly pieced together from cosmic whispers and the oldest light in the universe. This is the story of our cosmic origins, a journey spanning 13.8 billion years, from the fiery birth of the universe to the calm, blue planet we call home. We will trace the incredible chain of events, the monumental forces at play, and the almost unbelievable coincidences that transformed a chaotic void into a vibrant, living world. Prepare to witness the birth of stars, the swirling dance of gas and dust that became our sun and planets, the cataclysmic impact that gave us our moon, and the gradual, painstaking process that laid the groundwork for life itself. This isn't just a history, it's the ultimate origin story, a testament to the immense power and intricate beauty of the cosmos. By the end of this journey, you will never look at the night sky, or indeed, your own existence in quite the same way again. This is the unwritten history, now brought to light. Historical context and setup. To truly appreciate the improbable journey that led to our existence, we must first set the cosmic stage. Our story begins not with a bang, but with the Big Bang, an event that marks the origin of our universe approximately 13.8 billion years ago. Picture an infinitesimally small, unimaginably hot, and incredibly dense point. Then, in an instant that transcends human comprehension, it began to expand. This wasn't an explosion in space, but an expansion of space itself. It was the birth of everything: space, time, matter, and energy. In the immediate aftermath, for the first few minutes, the universe was a superheated, opaque soup of fundamental particles, quarks, electrons, and their antimatter counterparts. As this primordial cosmos expanded, it cooled rapidly, allowing these particles to coalesce. Protons and neutrons formed, and then, in a cosmic alchemy, these combined to form the nuclei of the lightest elements, hydrogen and helium. This epoch of creation was intense, chaotic, and unimaginably energetic, laying the very foundation for all matter that would ever exist. For the next 380,000 years, the universe remained a dense, glowing plasma, a cosmic fog so thick that light could not travel freely. Electrons were still too energetic to bind with atomic nuclei. But as the expansion continued, the universe cooled to a critical temperature, roughly 3000 Kelvin. At this point, electrons finally combined with atomic nuclei to form neutral atoms of hydrogen and helium. Suddenly, the universe became transparent. The light that was unleashed at this moment, after traveling for 13.8 billion years, is what we now detect as the cosmic microwave background radiation, an echo of creation itself, a faint whisper from the dawn of time. Following this recombination, the universe entered a period known as the Dark Ages. There were no stars yet, no galaxies, just a vast expanse of neutral hydrogen and helium gas, slowly expanding in the cosmic void. Yet within this seemingly empty canvas, gravity, the silent architect of the cosmos, was at work. Tiny fluctuations in density, mere ripples in the cosmic fabric, began to grow. Over hundreds of millions of years, these denser regions gradually pulled in more and more matter, like cosmic snowballs gathering mass. Eventually, these clumps became so dense that their internal pressure and temperature ignited nuclear fusion, giving birth to the first stars. These primordial stars were colossal, blazing furnaces, dramatically different from our sun. They burned fiercely and died quickly in spectacular supernova explosions, scattering the heavier elements they had forged: carbon, oxygen, iron back into the interstellar medium. This was a critical step. The universe was no longer just hydrogen and helium. It was being seeded with the very building blocks of planets and ultimately life. Fast forward many billions of years. Our galaxy, the Milky Way, had formed, a swirling disk of billions of stars, gas, and dust. Around 4.6 billion years ago, within one of its spiral arms, a vast, rotating cloud of interstellar gas and dust, a nebula rich in these newly forged heavy elements, began to stir. Perhaps a shockwave from a nearby supernova triggered its collapse, or perhaps it was simply its own immense gravity. Whatever the catalyst, this solar nebula began to contract, spinning faster and flattening into a colossal disk, much like a cosmic pizza dough being stretched and spun. At the very center of this collapsing, spinning disk, the vast majority of the nebula's mass accumulated. The pressure and temperature at this core became so extreme that hydrogen atoms began to fuse into helium, unleashing an immense amount of energy. The sun was born, a brand new star, radiating light and heat across the fledgling solar system. This was the moment our star ignited, becoming the gravitational anchor and life-giving furnace for everything that would follow. Now, imagine this disk of leftover gas and dust orbiting the young sun. It wasn't smooth. It was a turbulent, dynamic environment where dust grains, no bigger than specks of soot, began to gently collide and stick together. Over millions of years, these microscopic particles grew into pebbles, then rocks, then boulders. This process, driven by electrostatic forces and later by gravity, is called accretion. As these planetesimals grew, their gravitational pull became stronger, attracting even more material, sweeping up the debris in their orbital paths. Around 4.5 billion years ago, one such accumulation of planetesimals was forming at a comfortable distance from the Sun, our Proto-Earth. It was a chaotic, violent birthplace. The growing Earth was a world constantly bombarded by incoming asteroids and comets, each impact adding mass and immense heat. This ceaseless barrage kept the young Earth largely molten, a fiery, glowing sphere of liquid rock. This was a planet still finding its form, a world of unimaginable heat and constant reshaping, but it was on its way to becoming something truly extraordinary. The story unfolds the Proto-Earth, a fiery ball of molten rock, continued its violent accretion, growing larger with every impact. But something remarkable was happening within its superheated interior. Due to the intense heat and the relentless pull of gravity, the planet began to differentiate. Heavier, denser elements like iron and nickel, in their liquid state, slowly sank towards the center, forming a molten core. Lighter silicate materials, meanwhile, rose towards the surface, forming the planet's mantle and a thin, unstable early crust. This differentiation was a pivotal moment, giving Earth its layered structure, a fundamental aspect of its future geological activity and the eventual development of a magnetic field. Then, around 4.5 billion years ago, an event occurred that would forever alter the destiny of our planet, a cosmic collision of staggering proportions. Imagine a rogue planet, roughly the size of Mars, hurtling through the early solar system. Scientists call this hypothetical body Theia. Theia was on a collision course with the Proto-Earth. This wasn't a head-on impact, which would have likely shattered both worlds, but a glancing, colossal blow. The impact was so violent, so energetic, that it vaporized vast portions of both Theia and the Proto-Earth's mantle. The immediate aftermath was a sight beyond anything we can conceive. A colossal plume of molten rock, vaporized material, and superheated gases erupted into space, forming a massive, glowing ring of debris orbiting the newly reshaped Earth. The sheer energy of this giant impact was enough to remelt much of Earth's crust and upper mantle, leaving it once again a fiery, incandescent sphere. This was no gentle formation. It was a cosmic catastrophe that paradoxically led to one of Earth's most vital features. Within a relatively short period, perhaps just months or years, this swirling disk of debris began to coalesce. Under the relentless pull of gravity, the molten fragments and gas particles clumped together, gradually forming a single, large body. Our moon was born, a direct result of this cataclysmic collision. It formed close to Earth, much larger and hotter than it is today, a constant reminder of the violent event that forged it. Its existence was not just a cosmic coincidence, it was a game-changer for the future habitability of our planet. The newly formed Earth, though still incredibly hot, slowly began its long process of cooling. Volcanic activity was rampant, spewing vast quantities of gases into the nascent atmosphere. This primordial atmosphere was a toxic brew, rich in water vapor, carbon dioxide, methane, and nitrogen, but critically, almost entirely devoid of free oxygen. Imagine a landscape dominated by lava flows, fiery skies, and a constant rumble of eruptions. This was the Hadean Eon, often called the hellish Eon, a period of immense geological change. As Earth continued to cool over hundreds of millions of years, a monumental shift began to occur. The water vapor, which had been locked in the thick, hot atmosphere, started to condense. Imagine clouds forming on a scale never seen before, leading to torrential, unrelenting rainstorms that lasted for millions of years. This ceaseless downpour gradually filled the lowest basins and valleys of the Earth's cooling crust, forming the first oceans. This was a truly transformative moment, marking the arrival of liquid water, an absolutely essential ingredient for life as we know it. The Earth was transitioning from a fiery inferno to a watery world. During this period, roughly between 4.1 and 3.8 billion years ago, Earth also experienced the Late Heavy Bombardment. This was a prolonged era of intense impacts from asteroids and comets, a violent cosmic cleanup operation. While these impacts caused immense destruction, they also potentially delivered significant amounts of water and complex organic molecules to Earth's surface, enriching its chemical environment. It was a double-edged sword, a period of devastating impacts that also might have sown some of the seeds of life. As the Hadean Eon gave way to the Archean Eon, Earth's crust stabilized further. Early continents began to form, though they were much smaller and more numerous than today. The oceans were vast and filled with a rich chemical soup. The atmosphere remained largely oxygen-poor. It was in these primordial oceans, amidst the complex chemical reactions fueled by volcanic activity and energy from the sun, that the most profound transformation of all began to stir. The raw ingredients were there: water, energy, and organic molecules. The exact process remains one of science's greatest mysteries: abiogenesis, the origin of life from non-living matter. However, around 3.8 to 3.5 billion years ago, the first simple, single-celled organisms, prokaryotes, emerged. These microscopic pioneers, likely thriving in environments like hydrothermal vents on the ocean floor, began to replicate, evolving and adapting to their primordial world. They were the ancestors of all life, the first tiny sparks in the grand biological saga. A pivotal moment in Earth's history, and indeed the history of life, occurred with the evolution of photosynthesis. This revolutionary biological process, first developed by cyanobacteria, allowed organisms to harness sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. Slowly, over billions of years, this waste product began to accumulate in the atmosphere. This was the Great Oxidation event, a transformation so profound it fundamentally changed the very air we breathe. This gradual oxygenation of the atmosphere was a double-edged sword. For many anaerobic life forms, oxygen was a deadly poison, leading to mass extinctions. But for others, it presented an incredible opportunity. It paved the way for the evolution of aerobic respiration, a much more efficient way to generate energy, which in turn enabled the development of more complex, multicellular life. The Earth was now a truly living planet, its geology, atmosphere, and biology locked in an intricate, co-evolving dance. Meanwhile, beneath the surface, the Earth's internal heat continued to drive the slow but relentless process of plate tectonics. Continents drifted, collided, and reformed, building mountains, opening oceans, and dramatically reshaping the planet's surface over hundreds of millions of years. This geological dynamism, fueled by the core's heat and the mantle's convection currents, constantly recycled materials, released gases, and influenced climate, providing a constantly changing canvas for life's ongoing evolution. The Moon, silently orbiting above, also played a crucial, often underestimated role. Its gravitational pull stabilized Earth's axial tilt, preventing dramatic wobbles that would have led to extreme and unpredictable climate swings. This stability provided a more consistent environment over geological timescales, allowing life to evolve and diversify without being constantly reset by chaotic planetary conditions. The Moon also generated powerful tides, rhythmically stirring the primordial oceans, potentially aiding the mixing of chemicals essential for early life. From a single point of unimaginable energy, through the forging of stars and elements, the swirling of nebulae, the violent accretion of planets, a cataclysmic impact, and the slow, steady processes of geology and biology, our planet and its steadfast companion were born. This long, arduous journey, filled with chaos and cosmic chance, ultimately laid the foundation for the extraordinary diversity of life, and indeed, for the consciousness that now seeks to understand its own origins. Impact and legacy, the immediate outcomes of this grand cosmic narrative were nothing short of revolutionary. First, the universe itself, from an unimaginably dense point, expanded into the vast, structured cosmos we observe today, complete with galaxies, stars, and dark matter scaffolding. Second, our solar system achieved a stable, organized arrangement, with the Sun providing the energy and the planets, including Earth, settling into their orbits. But for us, the most profound immediate outcome was the formation of a differentiated Earth, a planet with a molten core generating a protective magnetic field, a dynamic mantle driving plate tectonics, and a solid crust. Crucially, the giant impact created the Earth-Moon system, a unique celestial pairing. This large moon, as we've seen, immediately began to exert tidal forces and, more importantly, stabilized Earth's axial tilt, preventing extreme climatic shifts that would have rendered our planet far less hospitable. The long-term legacy of these cosmic and planetary birth events is nothing less than the habitability of Earth and the very existence of life. The stable climate, the presence of liquid water, the protective magnetic field shielding us from solar radiation, and the atmosphere, eventually enriched with oxygen, all converged to create a unique cradle for biological evolution. Without this specific sequence of events, without the Big Bang providing the atoms, without the stars forging the heavier elements, without the solar nebula forming our Sun and Earth, and critically, without Theia's dramatic impact, the conditions required for life might never have materialized. Consider a comparative perspective. Mars, our neighbor, also formed through accretion, but it lacked a significant moon-forming impact. Its smaller size meant it cooled faster, leading to a weaker magnetic field that eventually dissipated. Without this shield, Mars's atmosphere was stripped away by solar winds, turning a once potentially watery world into the desolate, arid planet we see today. Venus, closer to the Sun, experienced a runaway greenhouse effect, becoming an inferno of extreme temperatures and crushing atmospheric pressure. Earth's specific history, particularly the Moon's influence, stands in stark contrast, underscoring the delicate balance required for habitability. The legacy of our origins stretches directly into the modern world. Our scientific understanding of these events underpins astrobiology, the search for extraterrestrial life. By understanding how our own planet became habitable, we can better identify potentially life-sustaining exoplanets orbiting distant stars, guiding the next generation of space telescopes and missions. The ongoing study of lunar samples continues to refine the giant impact hypothesis, while cosmic microwave background observations push the boundaries of our knowledge of the early universe. Furthermore, this grand narrative provides a profound cosmic perspective on humanity's place. We are made of stardust, quite literally. The atoms that compose our bodies were forged in the hearts of ancient, exploding stars. Our existence is intertwined with the evolution of the cosmos itself. This understanding shapes not only our scientific endeavors, but also our philosophical and existential inquiries, prompting us to ponder the uniqueness of life and the immense, beautiful, and sometimes terrifying universe we inhabit. Reflections and Lessons: The Story of the Universe, Solar System, Earth and Moon's Birth offers profound insights into the nature of existence itself. It teaches us about the immense power of fundamental forces, the incredible timescales over which cosmic drama unfolds, and the delicate balance required for a planet to become a cradle of life. We learn that creation is often born from chaos, and that seemingly destructive events can, paradoxically, be essential for establishing new orders. What universal patterns can we discern from this grand narrative? The principle of accretion, small pieces coming together to form larger wholes, is fundamental, from the building of atoms to the formation of galaxies. The constant interplay between gravitational collapse and expansive forces, between intense heat and gradual cooling, drives cosmic evolution. And perhaps most importantly, the story reveals that the conditions for life are not just about a single factor, but a complex, interconnected web of geological, astronomical, and chemical processes. It's a symphony, not a solo. Here are some questions to ponder, questions that echo through the vastness of cosmic time and space. What if the Big Bang had unfolded with slightly different initial conditions? Would a universe capable of supporting stars, planets, and life ever have arisen? How unique is the giant impact that formed our moon? Could such a precise, life-enabling collision be a rare cosmic accident, or is it a common mechanism for creating habitable worlds? If other Earth-like planets exist in the universe, what specific combination of geological and astronomical events would be necessary for them to develop complex life, or even intelligent life? Given the immense timescales involved in cosmic and planetary evolution, how does this scale change our perception of human history and our fleeting presence in the universe? What can the extreme conditions of early Earth and the resilience of early life teach us about the potential for life in extreme environments elsewhere in the solar system or beyond? The universe is composed mostly of dark matter and dark energy, whose nature we barely understand. How does this fundamental mystery influence our grand narrative, and what does it tell us about the limits of our current knowledge? The Great Oxidation event dramatically changed Earth's atmosphere and life. Could similar planetary transformations be occurring on other worlds, shaping their evolutionary paths? If our understanding of the universe's origin is still evolving, what new discoveries might fundamentally change our current grand cosmic narrative in the next century? These questions remind us that the story is far from over. Our journey into understanding our cosmic origins is a testament to human curiosity, perseverance, and the boundless mysteries that still await discovery. Outro. So, we have journeyed through an unimaginable expanse of time and space, from the fiery genesis of the universe to the emergence of life on our vibrant planet. We've witnessed the Big Bang, the birth of stars, the formation of our solar system, the cataclysmic impact that forged our moon, and the slow, arduous processes that made Earth a habitable haven. This is our origin story, written not in ancient myths, but in the immutable laws of physics and the geological record of our world. It is a story of immense power, profound beauty, and incredible luck. Every atom in your body, every breath you take, every thought you think is a direct link to this ancient cosmic past. The stability of our seasons, the ebb and flow of our tides, and the very existence of a stable environment for life are all legacies of these monumental events. The moon, born from fire and violence, became Earth's steadfast guardian, its silent companion through billions of years of evolution. But the story of the cosmos, and our place within it, is far from complete. There are countless other chapters waiting to be written. Perhaps you'd be interested in exploring the incredible journey of life after its emergence, diving into the Cambrian explosion and the diversification of species that followed. Or maybe the ultimate fate of our universe, from the chilling possibilities of a big freeze to the dramatic implications of dark energy, sparks your curiosity. And what about the ongoing search for extraterrestrial life, asking if this grand cosmic narrative has played out elsewhere, on worlds we are only just beginning to discover? Each of these tales builds upon the foundation we've explored today, weaving a richer tapestry of cosmic history. This grand narrative reminds us of our deep connection to the universe, humbling us with its scale, yet inspiring us with the sheer improbability of our existence. So, the next time you look up at the night sky, remember the unwritten history, the epic saga that led to you, to us, to everything. We are but a tiny, precious part of an unbelievably vast and ancient story, a story that continues to unfold, moment by moment, across the cosmos. Thank you for joining us on this extraordinary journey.